Hello everyone. So starting by discussing the worksheet about mechanical actions, we first started defining the force. The force is a push or pull exerted by one body on another body. So here I stressed on push or pull. يعني if we take for example trying to pull the wagon to move it, this is a force exerted by your hand on the wagon. Trying to kick the ball. Kicking the ball is a force exerted by your leg on your ball. Okay? So in this way we are exerting forces or the so-called mechanical actions. So the body exerting the force is called the actor, while the body that receives the force is called receiver. Taking again the same examples, pulling the wagon. فإذا now you are pulling the wagon, so you are the actor, you are the one doing the force, while the wagon is the receiver, it is the object receiving the force. The other example, kicking the ball, you are the or your leg is the actor, it is the object exerting, doing the force, while the ball is the object receiving the force, so it is the receiver. This is as a definition. Now for the effect of the force. Sometimes we exert a force and we notice its effects. Other times the effects are not recognized. Let's suppose that, or let's take the first example shown in figure 1. As you can see in figure 1, the same example that I mentioned above, it is kicking the ball. So in figure 1, the force is exerted by the foot here on the ball. What is the effect of the force? It is setting the ball in motion. As we kick it, or as the boy kicks the ball moves. So what is the effect of this force? It is setting the ball in motion. Moving to the second figure, exerted by the magnet on the sliding small iron ball. يعني initially we have an iron ball here sliding, okay, sliding on the inclined plane. عم تزحف نزول. Whole different positions for it. Without the presence of the magnet, the ball remains sliding on a straight line, right? If we approach a magnet near it, we can see that instead of moving downwards along the inclined plane, the ball deviates towards the magnet. So in this case, the magnet is exerting a force, a pulling force on the falling or on the sliding iron ball. What is the effect of this magnetic force? It is changing the direction of motion. Yani instead of moving downwards as was shown in the first part, okay, we can here see that the ball deviated. So the effect of the force exerted by the magnet on the ball is changing the direction of motion of the magnet, or in other words, modifying the motion. Modifying the motion, when we say modify the motion, we either change the direction or the speed, okay? Finally, for the third figure, a man trying to break down exerting a force in order to break down a piece of wood. So this force is exerted by the hand of the man on the piece of the wood. Here the hand is the actor and the wood and the piece of wood is the receiver of the force. What is the effect of this force? What changes did this force cause on the piece of wood? It deformed it. So now when we want to study the effect of the force, we have to look on the receiver. Okay, effect of the force, in other words, on the receiver, or more specifically on the receiver of the force. It is deforming the piece of wood. It was deformed. It changed its shape. It changed its size. Okay. So here the effect of the force is changing its shape and size. Now you have to memorize these three effects. So the three main effects of any force could be set it in motion, changing or modifying the motion either by changing the direction or by changing the speed. And the third effect is deforming the piece of wood. Or not the piece of wood, deform. In general, deforming the receiver. Now, the third part is the types of forces. After defining the forces and discussing their effects, we need to classify these forces. They are classified into two types: acting at a distance, forces acting at a distance, or contact force. So here also you have to memorize the two types. You have to differentiate between these two. Between these two types. The instructions here are to name and classify the forces demonstrated in figures 4 till 12. Starting with figure 4. As we can see in figure 4, a man sitting under an apple tree. In figure 5 we have a magnet and in figure 4, and there's an apple falling down to the ground from the apple tree. In figure 5 we have a magnet attracting a nail. In figure 6 we have negatively charged body being attracted by a positively charged body. Can you see here the arrows? They are directed towards each other. يعني here the negative one and the positive one are attracting each other. Then on the other hand, we have two positively charged bodies. They are repelling each other. Here the arrow must be different. It must be as such. Let me show you this way. So here it must be the opposite way around. So the two positively charged bodies repel each other. Positive, negative attract. However, if we put here a negatively charged, here as you can see the two negatively charged bodies are repelling each other. The arrows are opposite to each other. Okay. In the figure 7 we have a box on the horizontal table and a box sliding on an inclined plane. In figure 8 there is a kitty, holding balloons that are positively charged. In figure 9, a support with a spring holding a certain mass of body. In figure 10, a car moving on a rough road and another car moving on a smooth road. In figure 11, a person, a worker, moving the wagon here, pushing it. And in figure 12, windmill and a sailboat being moved by the winds, and the windmill here rotating due to the presence of blowing wind. What are the instructions here? They are name and classify the forces demonstrated in figures 4 till 12. Okay, so the force here is being defined in figure 4. The considered force is the force exerted by the earth on the apple. What is the name of this force? Why does the apple fall down to the ground? We all know that it's due to the gravity. The gravity, what is the source of the gravity? It is the core of the earth. So, the force exerted by the earth on the falling apple, or on the apple causing it to fall down, is called the gravitational force. So what is the name? The name is the gravitational force. We don't say gravity, we say the gravitational force. What is the type of this force? In order to be able to classify the forces, we have to study or to check whether the actor and the receiver are in contact, are touching each other's or not. Earth and the apple. The apple, when being hanged here or dangling from the tree, from the branch of the tree, is it in contact with the core of the earth? Of course not. Still, the earth could pull it downwards. So they are not in contact, they are away from each other at a certain distance, but still the earth exerts a downward gravitational force on it. That's why we classify the gravitational force to be a force acting at a distance. Take the second example, figure 5. Figure 5, we are considering here the force exerted by the magnet on the nail. The magnet is the actor and the nail is the receiver. What do we call this force? What is the name of this force? It is a magnetic force, as you can see. What is the type of this force? It is acting at a distance. Why? Again, since the actor, which is the magnet, and the nail, which is the receiver, are at a certain distance away from each other. In other words, the magnet can pull the nail towards it while being at a distance away from it. So the magnet exerts a pulling force on the nail while being at a distance away from it. That's why we consider we classify the magnetic force to be a force acting at a distance. Figure 6, we have negatively charged bodies, positively charged bodies, and negatively and positively charged ones. So the force exerted by a charged body on another, since here we are considering charges, positive charges and negative charges, then we are talking about electric force. So the name of the force here is electric force. I want here just to point that the electric force could be a force of attraction or a force of repulsion. If the two charges are the same, and if I have a negative and a negative charge just like here, the electric force is a force of repulsion. Similarly, كمان having the same charges, both are negatively, they are going to repel each other. See? So repel as was initially shown. هون repelling, if I'm considering the interaction between these two positively charged ones, they repel each other. The electric force here is a force of repulsion, but still we name it an electric force. While for the third example, having opposite charges, they attract. The electric force here is a force of attraction. For figure 7, exerted by the table plane on the box. We said that there is a gravitational force exerted by the earth on the box or on any object on earth. How comes while setting this box on the table it doesn't fall down to the ground? This means that there is another force being exerted on the box and it is opposite to the gravitational force, right? يعني عندي أنا الأرث is pulling it downwards. However, this box is not falling down to the ground. Why? لأنه the table here exerts a normal reaction of support, an upward force that is opposite to the downward gravitational force, thus preventing it from falling down to the ground. Similarly here, in the inclined plane, a box is sliding down. Why doesn't it fall downward vertically? لأنه again the table here is exerting a normal reaction of support. Why is it called so? It's called a normal reaction of support since it is always perpendicular to the support, and we are going to show this later on while discussing this sheet. Figure 8, exerted by the rope on the balloon. Type. If we leave the balloon usually free in the air, it's going to flow in the air, right? What prevents it from falling? It is the force exerted by the rope on the balloon. The force exerted by the rope on the balloon is called a tension force. And it is considered to be a contact force. Sorry, I forgot to mention here, since the actor, which is the table, and the receiver, which is the box, are in contact, so we consider the normal reaction of support to be a contact force. Similarly here, the rope and the balloon are in contact, so the tension force is considered to be a contact force. Okay? In figure 9, كمان, what prevents this mass body from falling down to the ground due to the gravitational force? It is due to the force exerted by the spring on the mass body, and I still name this force as tension force. So, since the rope and the spring are elastic bodies, capable of being compressed and elongated in a way or another, they are not rigid bodies. That's why we call the force exerted by them a tension force. So, tension force is considered with elastic bodies that are not rigid, that are capable of being compressed or elongated. So, what prevents this mass body here from falling down to the ground is the tension force exerted by the spring on the mass body. It's always along the spring, and in this case it is upward, and we are going to discuss it and represent it later on while discussing this sheet. So now we have three forces acting at a distance: the gravitational, magnetic, electric, and two contact forces: normal reaction of support and the tension force. Moving to the figure 10, we have two cars, one moving on a rough road, and the other moving on a smooth one. Uh, so we can here the force is exerted by the rough ground on the wheels. Of course, if it is rough, the car won't be able to move uh, easily due to the friction force exerted by the ground on the car, and the friction force is always opposite to the direction of motion. It opposes the motion. However, if the road is smooth, so it's easy going here, no friction force opposing the motion, so the motion is easy. This force is again considered to be a contact force because the ground exerted by the ground on the car, or on the wheels actually, specifically on the wheels of the car, so it is a contact force.